as we can. So looking at this one, you're just going to work backwards for this. It's a simple one, but it is memorization. You have to remember which trig function, I'll give you a hint, it's not sine or cosine, it's one of the other four, gives you this as the derivative. Basically, who is cosecant's buddy? Which one? Good job, cotangent. And then you have to put plus C. The derivative of cotangent is negative cosecant squared. That's good review back from unit 3 with all our derivative rules. You got to know them. All right, so it's a simple problem. There's no work to it, but you have to know them. All right, this is find the particular solution with this initial condition. So first thing, we're going to divide over the y minus 3. So that moves to the other side. Since we divided, I put it in the denominator. And then equals, what do we have on the right side? Yeah, x minus 1 dx. Perfect. So we got it separated. Then we're going to do the antiderivative. What do we get on the left side for our antiderivative? If I cover this up, what is it? ln y. So it's going to be ln y minus 3. It's technically a u substitution. I just don't write it out because nothing happened. But as a follow-up question, say instead of y minus 3, it was 2y minus 3. Then out front, you would put a 1/2. Say it was a 5y minus 3. Then out front, you would put a 1/5. Okay, but I don't want you to do all the work. All right, equals antiderivative for this side. 1/2 x squared minus x plus c. And then you're going to plug in. Now, if you want to draw a little arrow, this helps some people. This is the step we're going to go back to, but we're going to plug in 6 for x and 4 for y. So if y is 4, 4 minus 3 is 1, ln of 1 is 0. If we plug in 6 for x, all right, 6 squared is 36, half of that's 18, minus 6 is 12. Oops. So C is negative 12, if I could write here. So we're going to go back to the line where I put the arrow, draw it like it's a picture. Sorry, write it exactly, like just copy it. Except instead of plus C, put minus 12. And then from there on, you're done with calculus. You're just trying to get the y by itself. So how do you get rid of ln? E, so it's going to be e to the power of, like, all of that. And then what's your last step to get the y by itself? Add 3. So the plus 3 just kind of gets tacked on at the end. And then that's your final answer. All right, let's try another one. This is very much like the u substitution you did. It's very dry and boring. You just follow the steps and get your answers. All right, find the particular solution with the initial condition y of pi equals e to the third. Pi is a number and e is a number. So those are just numbers. It just, you know, looks a little strange. How would you separate this? How are you going to move over the y? Divide by y. Oh, good. So it's 1 over y dy equals, and then what's still on the other side? 2 sine x dx. All right, antiderivative. The left side is going to be ln y. What do you think about the right side? Good. Negative 2 cosine x plus c. Now, if you want to draw a little arrow, that's the step we're going to go back to. We're going to plug in pi for x and e to the third for y. All right, if you plug in e to the third right here, ln e to the third, ln and e cancel, so it would just be 3. ln e to the third would just end up being 3. Now pi, where is pi on your unit circle? The left? Cosine is x, so good. That's negative 1 times negative 2 is just 2. Good, you guys were on top of that. Nice job. All right, and so C is 1. So recopy the line where I put the arrow there. Just recopy it literally exactly like it looks, except +1 instead of plus C. And then your last step is E. So it's E to the power of all of that. Cool. Oh, let me bring this up. Do you see how this initial condition, the output was 4 and that's positive? You see how this is e to the third and that's positive? That's why I didn't put anything in front of here, but say those were negative, you'd stick a negative out front. Do you remember that? Okay, because in multiple choice land, they're probably gonna have one choice that's positive and one that's negative. So like just read carefully. All right, number 5. Same thing. Do it again. You're gonna divide over the y. They really like ln, so you do see that a lot. If you get that a lot, don't second guess yourself. They just like to do that a lot. All right, equals 1/2 x dx. And then your antiderivatives. So that's going to be ln y equals, what would we get on the other side? Good. Perfect. You guys are good with fractions too. 1/4 x squared plus c. So we're going to plug in 0 for x and 4 for y. So that would give you ln 4. You can drop the absolute value because absolute value of 4 is 4. Equals c, right? Because if x is 0, all that stuff goes away, which is kind of nice. We're going to go back and recopy that line, but put in ln 4 for c. And then your last step to get y by itself, you're going to do e to the power of all that. Now, e and ln cancel. You just get 4. And where do we write that? Out for good. So it's going to be 4e to the stuff. And again, the initial condition was positive, so you don't have to worry about putting a negative in there. Now, this one actually has one more step. Read the directions. We got the equation, so we did all of that, but it says then find, and all you're going to do is plug in 3 for x. That's all that is. So if you plug in 3 here, 3 squared, 9, so 9/4. So you'd have y of 3 equals 4e to the 9/4. You just plug in 3 for x is all that is. So I just got one extra step. I'm going to skip number 6. When I post this, the answer will be up there, but that one is almost identical to the second one on your quiz. So we did one just like that. So for the sake of time, I'm going to not do that. I don't want to do every single one on here because I want to leave some for you guys next time. All right. We will also skip number 8. So I think you guys will be okay with that one. All right, let's do, or I'm sorry, number 7. We'll go straight to number 8. It says a curve has a slope of 4x minus 1. What that means is dy dx is 4x minus 1. So you're just having to set it up yourself. Like they put it in words and you had to write it yourself. But slope means derivative dy dx. Are we all okay with that? Yeah. This is a notational thing. All right. And then you're going to just, solve, just keep going. What's easy about this one? Like, why is this kind of actually a nice problem? Yeah, you don't have any y in there. So when you go to solve this, y is already going to be by itself, which is kind of nice. I'll usually put a 1 in front of that dy. You don't have to, but I've found that that helps people remember what they're doing. So you're going to have y equals, and then what's your antiderivative here? You got 2x squared minus x plus c. That's the line we're going to go back to. All we have to do really is find c. So we're going to plug in -3 for x and 5 for y. So that'll give us 5 equals, let's see, -3 squared is 9 times 2 is 18 minus -3. So it'd be 18 plus 3, 21. So c is -16. And because y was already by itself, basically you're just going to rewrite that, but put in the -16 for c. So that was actually a real easy problem, but the way it was written, the problem doesn't have a dy dx anywhere in it. So you have to know that when it says slope, that means derivative is all that's really going on there. I think maybe we'll finish the page and then we'll do our break. These are going pretty quick though. Are you guys all still with me? All right, you can kind of start churning these out. This one I'm not a super huge fan of, but I saw a bunch of these on AP Classroom, so I was like, okay, well, we better do this. It says, for what value of k, so k is your goal, will this awful thing be a solution to this differential equation? Do you see how it says y prime prime? Okay. The first thing you're going to have to do is find y prime prime. So first we're going to find y prime. Can't jump straight there. And you have to remember all your derivative rules. K is not a variable. This is not a product rule, which is good because otherwise then it would be like this long. K is just like a number. So what is your derivative? I want to see if anyone gets this of this thing. Yeah, wouldn't it just be itself? But then you have to chain on derivative of negative 2x is a chain rule. So you have to chain on negative 2. So it will look like this. Yeah, exactly. It's not a product rule though, which is a good thing because that would be way more work. All right, now this one, what's your derivative of cosine? Negative sine, but that one also has a chain rule. You have to multiply on a 3. So negative, good, you guys got it. Negative 12 sine 3x. If you were like, hey, I didn't quite get that, don't worry, we're going to do it again because you have to do the second derivative. So what would be the derivative of this first part? They both have a chain rule in them. Good. Oh, you guys are getting it. 4k e to the negative 2x. And then derivative of sine is just cosine, but you have another chain rule. So it's, yeah, you got it. Minus 36 cosine 3x. I'm not going to recopy that. All right, so we're just going to use that. Now, we found y prime prime. That's this awful thing. It says plus 9y. Do you see where I'm pointing there? Yeah. So we're going to have plus 9 times y is all of this. So we're going to distribute a 9 into both of those. So it's going to be 9k e to the negative 2x. And if you multiply this by 9, what do you get? Good, 36 cosine 3x. And it says that that equals 26 e to the negative 2x. Now, that was annoying, I'll grant you. However, it's about ready to get a whole lot better. Look through this awful statement on the left side of the equal sign, all of this. What do you notice? Okay, those are gone. And then these two are like terms. So if you put them together, what do you get? Good. Okay, cool. You guys hung in there with me. 13k e to the negative 2x equals 26 e to the negative 2x. And then what cancels? Yeah, the e to the negative 2x is gone. You have 13k equals 26. Divide by 13, and k is 2. That is a trust the process problem. You have to just kind of go with it and see where you're headed, because once you did all of that, it actually ended up not too terrible. And again, every truly awful problem that you see, I did not make up. You know where I got it, and that's why I want to show it to you. Okay, you can't back down from those ones. All right, number 10. Which of the following, oh, this is another one that I find kind of annoying. Which of the following is the solution for this? Here's what I would recommend. I know there's noise in the hallway. I'm sorry. Do you need me to shut that, or can you all overcome and pay attention? Here's what you want to do. You want to find the derivative of each of these and see which one gives you that. Okay. For the sake of time, I'm going to go ahead and have us just work out the one that's the answer. But do you get what I'm saying? You'd find the derivative of each of these. Yeah. You actually can't solve this. It's what's called non-separable. You can't separate them. Just trust me, you can't. So here, I'm looking at what the answer is. The answer is D, but you'd have to test them all on your test. So let's find the derivative of this one. What rule would you need for that derivative? Product and change. Oh my gosh, perfect. Good, we're reviewing all the derivatives. So how does product rule start? The first thing, that's negative x, times the derivative of the second, which is where the chain rule comes in there. So first derivative of the second, good. Then you add plus second, good, times the derivative of the first is -1. If you wanted, if your personal preference is to put that in the other order, then that's fine. So you have negative x 4e to the 4x plus, well, I guess you could even write minus e to the 4x. But then you look at this, it's negative e to the 4x. Do you see how that's this part? That matches up with this. And then it's plus 4y. Well, do you see how y is this thing? So it's plus 4 times that. Do you see how this part matches up with this? And then plus 4y. Well, this is y. 4 times this is 4, negative 4x e to the 4. Anyway, the answer is D. You would just test A, B, C, and D until you got the one that matched. This is draw a slope field for this. We just did that in the warm-up. Actually, someone did the exact same thing as that, except with a negative in it over there. You can draw that at your leisure. I'm going to put this on Schoology so you can see it. But that's matching. It's multiple choice. So they're going to give you this, and then A, B, C, and D are going to be slope fields, and you have to pick the one that matches. That's how that's going to be. All right. We'll do 12, and then I'll explain 13. They're very similar. Where will this slope field have 0 slopes? Well, you would set the whole thing equal to 0 and then work some algebra. Greatest common factor, what can you factor out of both of them? A y. If you take out a y, what's left? X minus 1, good. And if you set both of those equal to 0, you get y equals 0 and x equals 1. So those are places where you would have 0 slopes. This is the same thing. You would set that equal to 0 and solve it. Where would x squared minus 25 equal 0, though? There's 2 places where that you don't really need the denominator. Where would this equal 0? 5 and negative 5 there. See, we did that one too. Cool. All right, so this again, it's going to be multiple choice. It's like which of the following graphs depends only on the y coordinate. And actually, I think it's a Roman numeral one. So it's like 1 only, 1 and 2, 1 and 3. Like, do you know what I'm saying? So basically, you could have something that's a horizontal line. And I need a new pencil. Or you could even have something that does this, something that's sort of like a swoop. Anything like that is okay. Basically, the only thing it can't do is curve back on itself. So you couldn't have something like this. Do you see what I'm saying? Like that would not work because all the rows wouldn't match up as the same slope. Because if it only depends on y, all your rows have to match up. And if it kind of like bends back on itself, those all won't be the same. But again, you'll just look at them and go, oh, yes to that one, no to that one, and whatever. So a parabola would not work either. Yeah, exactly. Like this. Because do you see how like this slope is not the same as this slope? So you couldn't have a whole row of slopes that would all be the same. So yeah, as long as it doesn't bend back on it, basically if it doesn't turn around, then it will be fine. All right, bacteria in a culture increase at a rate proportional to the number present. What formula is it? Remember PERT? Only now it's Kekek, okay? So the number of bacteria doubles in 6 hours. So I don't know what we started with, but we ended up with twice as much. With me there? Yeah. All right, so it's 2 equals e to the kt. I don't know what we started with, but what we ended up with is doubled. In how many hours will the bacteria triple? Oh, wait, it says it doubled in how many hours? Oh, I didn't plug in the 6. It doubles in 6 hours. So I need to put in 6 for time. And before we can answer that last question, you have to solve for k. We got to find k. And this is non-calculator. What would you do to both sides? ln, good. So ln of 2 equals 6k. And then you would divide by 6. So now we're going to repeat that, but we don't have the time, but now we have k. It's like you have the other thing that you didn't have before. So in how many hours will the bacteria triple? So you want 3 equals e to the power kt. K is that ln of 2 over 6. This time what we're missing is t. We don't have the time. So then we're going to start solving that. It's going to look like a great big mess. What would you do to both sides? Yeah, ln 3 equals ln 2 over 6 times t. And then to cancel that, you'd multiply by the reciprocal. So you would multiply by 6 over ln 2. So the 6 is going to go in the numerator and the ln 2 goes in the denominator. So it's going to look like that. So again, that was non-calculator. This next one's non-calculator too. I think I separated the calculator ones out at the end. Is that what I did? Yeah, those are at the very end. All right, so no calculator for this. A dose of 500 milligrams of medicine is administered to a patient. The rate at which it leaves the bloodstream is proportional to the amount present. When you see that, you need to think PERT. The rate is proportional to the amount present. That means PERT. What is a possible expression for the amounts in the bloodstream? We don't have any numbers to plug in, so we're just going to make it up. But we started with 500. And if it is leaving the body, what kind of a rate do we have? Yeah, it's like leaving, so negative. So an example would be y equals 500 e to the power, give me a negative number. Negative 2t or negative 3t, I don't know, whatever. It's going to be multiple choice. You're going to pick the one that has a negative if it's an amount that's leaving. Again, I just made up those numbers because we don't have any math to do. It's just what's a possible expression. Using number 16, write a possible differential equation. So the differential equation, dy dt, it equals k times y. K times, it's in your notes if you go back and look at it there. I promise I taught it to you. It's k times y. What did we make k for this one? Yeah, so it'd be negative 2y. Again, it's a possible differential equation. What's possible. So the equation itself is PERT. The differential equation is ky, k times y. All right, oh, here's our first free response one. Using that differential equation, sketch a slope field. All right, let's do this one. This will be a little bit annoying. On your test paper, I have the thing printed with all the little dots. For right now, you're going to have to just draw it. And I'll go. So can we knock out whole columns or whole rows at once? No, unfortunately, we don't. So we're going to have to plod along one at a time. Where is the point where we would be not differentiable? We get a 0 over 0. Indeterminate. Yeah, at 0, 0. So that one should be blank. Usually what I do is bold that one just to remind myself like, oh, I did that. It's just that there's nothing there. Then I would knock out all the 0 and undefined slopes. Anywhere the numerator is 0, we're going to get 0. So where x is 0, you get 0 slopes. So all of these will be 0. And any place y is 0, you're going to get undefined. So all of these will be vertical slopes. So bless you. So we knocked out like a quarter of them. So let's try and do the whole first row. For this whole first row, y is 2. That means our denominator would be 4. So try to hold that in your mind. For this entire first row, our denominator is 4. All right, the first x value is negative 2. If you plug in negative 2 times negative 5, you get, so 10/4. Yeah, like 2 and a little. Okay, so maybe like that. Again, it's not going to be perfect. Just in relation to each other, they need to make sense. Okay. And then this one, x is negative 1 times 5. So that would be 5/4, which is actually really close to 1, like 1 1/4. So it should be less steep than that one. And here's good news. For the other side, you can take those and flip them over. So something like that-ish. All right, let's do the next row. For the entire next row, y is 1. That means your denominator will be 1. It means basically you can ignore it, okay? So for your first x value, that's negative 2 times negative 5 is 10. 10 over 1 is a slope of 10. That's very, very steep. So like that, like practically vertical. And then for this one, you get -1 for x. -1 times -5 would be +5. So still really steep, but not quite as steep as 10. And then reflect those over here. All right, down here, y is -1. Oh, but if you square that, it'll be 1. So isn't that the exact same as the ones we just did? So don't reflect them, just literally copy the row we just did down here. It's going to be literally the exact same thing. Don't reflect it, just make it look the exact same. And then actually the same thing's going to happen with that last row, is going to be the exact same as the first row, because it's y squared. So when you square that, that's not going to change. So you can take this first row, don't reflect it, just copy it exactly for this one. It's hard to try and make them look the exact same. Struggle with that. So about like that. That's interesting. I don't know what I see there. Weird. Oh, well, there we go. You weren't asked to do anything else with it. Just draw it. So there, we're good. All right, write an equation. What two things do you need to write an equation? Point and a slope. Your point is right here, so that's good. Slope comes from derivative. Oh, look, here's our derivative. What are we going to plug in for x and y? Perfect. So if you plug in 2 for x, that'll be -10. And if you plug in -1 for y, you get 1. So your slope is -10. Put it all together. That's your point. That's your slope. It'll be y plus 1, good, equals -10, x minus 2. I think this is one of the easier problems, to be honest. All right, and then you're going to approximate 1.9. Why are you allowed to approximate 1.9? Close. Oh, those are perfect. All right, so y is approximately, now this is free response, and you're not allowed a calculator. So what I want you to do is nothing, okay? It's going to be -10, plug in your 1.9. Don't do anything to that. But you do have to get the y by itself. So what do you have to tack on at the end? Yeah, subtract the 1. Please do nothing to that, though. That is exactly what my answer key is going to look like. And if you try to work it out and have to stop what I'm doing, go and figure it out. Okay, leave it alone. Because if you mess it up, then it's going to be wrong. All right, and then this says solve the differential equation. Find the particular solution. All right, so what would you do to separate these? Multiply over the y squared. And then multiply over the dx. This one's not too bad. So antiderivative on the left side. Oh, I wrote an x. Awful. All right, 1/3 y cubed equals, good. That's the line we're going to come back to if you want to remind yourself. We're going to plug in 2 for x, -1 for y. So what would that give you on the left side? -1/3. And then over here, 2 squared is 4. What is that, -10? How many thirds is 10? 30. So this is -30 thirds. So if you add over 30 thirds, it would be 29 thirds. So you're going to recopy this line where I put the arrow there, except put plus 29 thirds. And then what are you going to do to start getting y by itself? Yeah, how do you get rid of a 1/3? Yeah, multiply by 3. So 3 times all of that stuff. Yeah, don't distribute it. Just leave everything alone. And then the last step, cube root. I think as far as free response go, that wasn't too terrible. I've seen worse. So have you, actually. Yeah, I think we'll finish the non-calculator before lunch, and then I'll stop the video there. Let me refamiliarize myself with this one because I remember this one being weird. All right, water is getting poured into a cylindrical container. The radius is 3. I'm going to try and draw a cylinder here. And the height is 30. It is not an incredible growing cylinder. The cylinder is staying the same size, just the water in it is changing, okay? But for the cylinder, the radius is 3. It's not changing. And the height is 30 in centimeters. That's not changing. The amount of water in it, the height for the water, like we'll call that H, that amount is changing. But the cylinder is not changing. This is a related rate. It's been a while since we've done this. So height is given by H in centimeters, time is in seconds. Volume is changing, volume of the water is changing at a rate of this. Show that dH dt, okay. Start with what they gave you. The volume is changing. How can we label this then? Derivative of dV dt. There we go. So that's dV dt. It's positive because the amount of water is growing, increasing. I'll leave this on the video. If it was decreasing, what is the volume of a cylinder? Because actually that's not given to you. You have to know that one.
1/3.
That's a cone. But it's what you were going to say. It's the rest of it, just without that part. Pi r. It's pi r squared times the height. You have to know that one. They won't give you ones like that. They won't give you usually a circle or a cylinder. They would give you a cone. They'll give you a sphere. Usually, they won't give you that one. Now, the height of the water is changing, so I need to leave H in there. Obviously, we're looking for dH dt. But is the radius of the water changing? No. What is R? R is 3. So you can go ahead and plug in 3 for R because it's not changing. It's constant. Anything that's constant is going to stay. So 3 squared is 9. I just wrote that in there. All right, and then we're going to get our derivative, dV dt equals, so what is your derivative of 9 pi h?
Oh, right.
Well, it's 9 pi. What was that? No, you guys are doing an antiderivative. I need a derivative. What is that? There we go. What's the derivative of 9h? Well, that would just be 9, right? So the derivative of 9 pi h is just 9 pi, but what rule is that? What rule is that we use to multiply on the dH dt? It is chain rule. I don't know what to tell you guys. That AP exam is coming. Do you see how many class blocks we got left until that? Derivatives and stuff. I know we've been doing antiderivatives for a lot. That's kind of why I threw this on here so that we could review it. All right, now what did they say dV dt equaled? 2 pi square root of h. So 2 pi square root of h equals 9 pi dH dt. What's going to cancel, thankfully? What have we got on both sides that's going to go away? Yeah, pi's are gone. And then you want to get dH dt by itself. So what would you do to get that alone? Divide by 9. Oh my gosh. Lo and behold, did that come out to what it says right here? Yes, it did. Do you see? Okay. Given that the height is 12 centimeters at time 0, that's an initial condition, solve the differential equation. That's why this showed up on this test, all right? How would you move over the square root of h? Would you multiply it or divide it? You would divide it. Now, don't write this, though. That would be h to the what? Because this doesn't help us. Good, perfect. dH equals 2/9 dt. Actually, I'll leave that on. It's going to erase that, but I'll leave it. All right, now you're going to do the antiderivative. So you add 1 to the power. So that would just be a half, and then in front of that, you would need to put 2. And then on the right side, it would be 2/9 t. If you put x, they'll forgive you for that, all right? Plus c. Like if you slip up and change it to x's and y's, they'll let that slide. All right, what was our initial condition? Time is 0. That's good because that goes away. And height is 12. So it would be 2/12 to the 1/2. I'm going to go ahead and write it as 2 square root of 12 because I don't feel like writing a 1/2. All right, and we're going to recopy this line. Only I'm going to write 2 square root of h because I just like that better. That's a personal preference thing, so it's kind of up to you. I just don't want to write the 1/2. 2 square root of h equals 2/9 t plus 2 square root of 12. If it looks like a mess, you probably did it right. Your last steps are get h by itself. So what would you do to get h by itself? And here's what I want you to do on your test and on the AP exam. Don't recopy it because the more you do that, the more likely you are to make a copy error. Just go like this. All right. And then what's your last step to get rid of the square root? Yeah, don't recopy it. Just do that. And then the last one, at what time is the container? So at what time is the container full? Well, we got to figure out how much is in it when it's full. It's 30, right? Or the height is 30 when it's full. Because h would have to be, oh, we don't need to actually find the volume. We just need the height when it's full. So the height is 30 when it's full. So we're going to put 30 equals this awful thing. But don't worry, I'm not going to make you rewrite it again because we're going to do the same trick and just sort of like scribble out the stuff we don't need. Now you just have to solve for t. So what would you do to both sides? All right, you'd square root. Normally there's a plus minus, but we don't do negative time. And then multiply by 2. So just stick a 2 out front. And then, now here I'm going to have to rewrite it. So 2 square root of 30 minus 2 square root of 12 equals 2/9 t. Yeah, but parentheses are important. So it's going to look like that.